All right, to do this, the first thing we want to start with is our have needs analysis. So we have the elements S, we have a Cl, and we have another Cl. So the first thing we have to do is figure out how many valence electrons does each element have. Well, we look on the periodic table to determine sulfur has 6 valence electrons, each chlorine has 7. You add that all together, so we have a grand total of 13 plus 7, which is 20. Okay? Now we need to figure out how many valence electrons do they need. Well, sulfur needs 2 to achieve a stable octet. Each chlorine only needs 1. So we're only going to be using 4 electrons in the bonding. That means we're going to have 16 valence electrons that are left over that are not going to be involved in bonding. So let's start by figuring out which one's going to be the central atom. Well, if we look at this and determine this, sulfur, we can tell sulfur is going to be in the front. The sulfur is going to be the middle because it needs to share an electron with each of the chlorines. So I'm going to put a sulfur here, all right, and I'm going to put a chlorine on either side of it. And I use the Cl, script Cl, to differentiate between C and I. So Cl. We now need to connect them with our valence electrons that are involved in bonding. So the valence bonding electrons, these ones here in red, we only have 4 to work with. Well, as it turns out, we can put 2 there and 2 there. So our 4 electrons are used to hook this entire thing together. We now have 16 valence electrons that are not involved in bonding. And so we have to assign those 16 valence electrons around the perimeter. So you start on the outside. And so chlorine now currently has 2, but now 3, 4, 5, 6, 7, 8. Of our 16 electrons we've used 8 of them. There's 6 of them, rather. 1, 2, 3, 4, 5, 6. We've now used 12 of them, meaning we have 4 left over. So the remaining 4 are going to go on here. And so now if we consider each atom in this arrangement, each atom in the bonding arrangement, the sulfur in the center, sulfur, it has 8 valence electrons around it. Each chlorine also has 8 valence electrons around it. So now we know that, okay, everyone has achieved its stable octet. So now once we've done this, we can rewrite this with sulfur, single bond to a chlorine, single bond to a chlorine, and then the unshared electrons are on the outside. All right, that's the same structure. Whoa, no twisting, just sliding. There we go. All right, so now we're going to ask, okay, we need to figure out, oh, not that one, not that thing. We need to figure out what's the central atom. The central atom is going to determine the shape. All right, so you have to first determine to which group on the periodic table does the central atom belong. Well, the central atom is sulfur. Sulfur is the central atom right here, okay? Sulfur is in group 16. And then you say, okay, group 16, how many things are attached to this group 16 element? Well, this one there are 2. So now we look at the sheet. So we flip to this sheet here, we're looking at group 16. All right, move this out of the way. Group 16, and we're looking at it's attached to 2 things. So if it's attached to 2 things, that means we have this bent or angular shape. The bent angular shape is the shape of this molecule. So now we're going to go back to that diagram there. And this is slowly catching up. Sorry about that. So now we're going to go back to this. Okay? So now we know this is a bent or angular shape. And so a better drawing of this would be the sulfur here, the chlorine down here, the other chlorine down here, and then the 2 unshared pairs of electrons right there. When we build it, when I build it, see if I can put this over top of maybe a piece of paper that's blank or something, okay? So if we look at this, and all right, so we're going to take a sulfur atom. We're going to take a sulfur atom. Let me scroll down, that way see a little better maybe. All right. So the sulfur atom is the red, is denoted by this, a red ball. All right, we're going to take 2 sticks that are attached to it. So I'm going to put a stick in each one of the 2 holes. Okay? And then we have two CLs, and chlorines are denoted by a green one. So attach the green, the other green, and you're going to see that it is indeed the bent angular shape. These molecular model kits are set up to simulate the same bonding angles. So that is the bent or angular shape. Let's look at another one, shall we? Let's look at, we take this, copy that. We take this and we'll look at, well, let's look at this one here, CFCl2. Okay, we have to do our have needs analysis. Our have needs analysis, we have a carbon, we have a fluorine, another fluorine, a chlorine, and a chlorine. Okay, so we have the haves, the needs, and then the extras. Okay, so chlorine has 4 valence electrons, each halogen has 7. All right, so we have a grand total of 7 times 4 is 28 plus 4 is 32. So we have 32 electrons, 32 valence electrons. However, we only are going to need, carbon is going to need 4, and each halogen is only going to need 1. So we're only going to need 8 electrons to bond with. That means, we're going to have some that are left over. The remaining ones are extra non-bonding electrons. That's going to be 24 non-bonding electrons left over. So move my this out of the way. So the central atom is going to be the carbon, because obviously it needs to bond with everybody. So carbon, and I'm going to put a fluorine, 2 fluorines and 2 chlorines around it like that. I could switch these fluorines or chlorines around. I could put this, don't need to do that. I could put this chlorine up here or over here, or where I could put the fluorine and chlorine on opposite sides. I love how it does that. That's just spectacular. Spin that around. Just so I can move it. Okay? So it really makes no difference, all right, where we put it. So now we're going to connect it with our bonding electrons. Our bonding electrons are going to be these red ones here, our bonding electrons. So we have 8 to work with. Well, we have 4 elements to bond to the central carbon. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. That takes care of all 8. I now have 24 non-bonding electrons that I have to assign. Those 24 non-bonding electrons, I need to start by putting them on the outside, and if I have left over, I can move to the inside. So 1, 2, 3, 4, 5, 6. That chlorine now has a stable octet. 1, 2, 3, 4, 5, 6. That fluorine has a stable octet. We're up to 12. 1, 2, 3, 4, 5, 6. Octet, we're up to 18. 1, 2, 3, 4, 5, 6. There's all 24. And so when we get finished with this, we realize that we have carbon that is singly bonded to 4 things. Carbon is bonded to a fluorine, bonded to a fluorine, bonded to a chlorine, bonded to a chlorine, and a whole mess of unshared pairs of electrons. We now say, okay, so to which atom on the periodic table, to which group on the periodic table does the central atom belong? All right, well, the central atom is carbon. Carbon is at group 14. This group 14 has 4 things attached to it. So we jump to here, group 14 that has 4 things attached to it. If we go to that and look, all right, over there we see carbon that has group 14. 4 things attachment is going to be the tetrahedral shape. So the tetrahedral shape is the shape of this molecule. So we're going to jump back to our problem here. Jump back to it. So now we know it's tetrahedral. Tetrahedral, that's our shape. You recognize my L as a 1. Oh well, that's all right. So now we're going to move over to the molecular model kit. We take our molecular model kit. Extend this page out a little bit. Put this in here. All right. Our molecular model kit, we're going to grab a carbon atom. We're going to grab carbon. We're going to attach it to 4 things. We're going to put 4 bonds into it. 1, 2, 3, 4. Actually, I'm going to replace that one. That one looks like it's broken. We don't want a broken one. 4. All right, and I now have 2 chlorines, so I'm going to use the green ones as the chlorines. It says halogens can be green, purple, or orange. My kit, I have a whole bunch of orange. I have no purple, so I'm going to use orange, orange, orange. And so there's my molecular molecule. I can see right away that that is a tetrahedral molecule. All right, we can see it's tetrahedral because if we set it down, this space underneath here, it's held up above the plane. All right, that is a tetrahedral molecule, and that's that problem. So this is the kind of thing that you're going to do. You're going to work through these, and when you get to a molecule that you're having a tough time with, remember, start with the have needs analysis. Start with the have needs, work through that process, determine the central atom, look on that table, and that should help you figure out that table, that worksheet should help you figure out what shape that molecule is.